So for section 4.6, we're going to look at some counting methods, permutations, and combinations, and just kind of a couple. There's going to be a couple tricks that we do with this. It should make sense, and then I will get into how your calculator can do a lot of this. But the question is, first of all, how many different ways could 6 people shake hands, right? Well, think about that. If there were 6 people, the first person could shake hands with, well, 5 people. They're not going to shake hands with themselves. And the next person would not have 5 people because they already shook hands with the first one. So then there would be 4, then there would be 3, then there would be 2, then the last person would only have 1 person to shake hands with, right? And so how many different ways could all 6 of them shake hands? Well, it could be 5 for the first, second, or 4, 3, 2, 1. And using the multiplication principle from the previous section, we can multiply to get our number of ways. So if this person can shake with 5 people, this one with 4, that makes 20. 20 times 3 would be 60. 60 times 2, 120. 120 times 1. There are 120 ways to shake hands between 6 people. This is called factorial. Another way of doing this, and I have 6 factorial here just as an example, but 6 factorial, this is not like an excited 6. It's not saying 6, right? It basically means 6 times 5 times 4 times 3 times 2 times 1. So it's kind of a way that we can figure out how many ways something can happen. So this 6 factorial is basically all those previous answers times 6. So 30 times 4 is 120, times 3 is 360, times 2, 720. The example that we did up here would have been represented as 5. About 5 factorial. Your calculator can do this. So you do need to understand what this means, but your calculator can do this. So if I wanted 6 factorial, we would do 6. And then there's generally a button for symbols. And if you can't find that, you can always go to the catalog and work your way around until I find the symbol for the exclamation mark. But I have a button here for symbols, and the second one is an exclamation mark. So we just do, let's see if I can do that, 6 exclamation mark. And we said that was 720. And that means the same thing as 6 times 5 times 4 times 3 times 2 times 1. Either way. And same thing with 5 factorial would be our 120. So when I have this now, we said, well, how many ways could 30 people shake hands? Well, the first person could shake with the second one, third one, all the way down to, or we could just do, so 29 factorial, really big. What we would probably do at some point is write this in scientific notation. So 8.84 times 10 to the, and then count how many times it would need to move. So that's 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. We need to move 30 times. So, or you could have written the whole number out if you really wanted to. But the idea is that's a really big number. That's a lot of handshakes. Need a lot of soap at the end of that. But this is where we got to be careful. What does 1 factorial mean, right? When we're doing factorial, it's basically another way of saying ordering. If I had 6 people, how many different ways could I put them in order? So if I had reordering 6 people, that would be 6 seats, right? How many people could go in the first seat? Well, 6. How many in the second? Well, we placed one of them, so 5, 4, 3, 2, 1. We can order 6 people 720 different ways. Why am I bringing that up here? Because up here I have 1 factorial. How many ways can I order 1 person? Yeah. But what does 0 factorial mean? How many ways can I order notebooks? How many ways can I put those in order? That is still 1. See, that confuses people, and they're like, no way, you're wrong, you're lying. Well, look, 0 factorial. How many ways can we order nothing? Is one way. Mathematically, it seems weird, but if you think about it as ordering, then that's where that makes a little more sense. This builds into our next question. How many different ways could we order or rearrange the letters in the word statistics? Well, it's the same idea. We have 1, 2, 3, 4, 5, 6, 7, 8, 3, 6, 7, 8, 9. I see 10 letters. So ordering 10 letters would just be 10 factorial. That is not our answer this time, though. You're like, well, why not? Well, I'm going to argue that 3 of these letters right here, if I rearrange them, would not make a difference. If I put those in different places, it still says the same thing. So what we have to do is we have to take this number of letters, factorial, and we divide it by any numbers or any letters that repeat. And we can add multiple down there. So the idea is, how many different ways could I rearrange these 3 that wouldn't count, that would not basically change the word? That would be 3 factorial. So what that would do is tell us how many different ways could I rearrange 10 letters and basically cancel out all of the changing of S's. That is still not our answer, and I'm hoping you're noticing that there are other options here. There's also 3 T's, which means we would have another. There's also 2 I's, which means there and there, which means we'd have another. So how would we do this? I mean, yes, you can do this all on your calculator, but this is one where I would just do and then I'd start canceling. So 3, 2, 1, 3, 2, 1, and then 2, 1. And so I could cancel 3, 2, 1 with 3, 2, 1. I could cancel that 3 and 2 is a 6. I could cancel that with a 6. I could cancel that 2 with that 4 and make that a 2. So, I mean, you can start canceling and then just multiply what's on the top. 90 times 8 is 10, 9, 8, 7, 5, 2 is what I'm looking at. So 10, 9, 8, 7, 5, 2 is all I had left on the top. So 50,400. Or, and if you're going to do the fraction, do control, divide, to set up that top and bottom to keep track of it. 10 factorial, really excited, divided by, we had a 3 factorial, another 3 factorial, and a 2 factorial. And I get that same answer. But be careful, that is not the same thing as 10 divided by this would not be the same answer because that 3, 3, and 2 have to be grouped on the bottom, and that's not what would happen this time. So be very careful if you're typing it in that way. Either group them top and bottom, put the bottom in parentheses, and our correct answer for this was 50,400. Okay? So yeah, there's going to be times where we use formulas for sure, but you can expect on the quiz and expect on the test some that literally is just should be very logical on how we order these things. License plates. If you have 6 spaces, numbers, and letters, how many possible license plates are there? Well, generally with license plates, we have 26 letters. We don't do upper and lowercase, and we have 10 numbers, ranging from 0 to 9. Okay? So if I am going to this first space, we have 26 letters and 10 numbers. That allows 36 options for that. How many would be on our second space? 36. Why isn't it changing? We're saying with repetition. We're allowing that 36 to occur over and over and over again. So how many times will it occur? Well, 6 spaces. And we use the multiplication principle. So basically 36 to the 6th. really big. 21767. 82336. Well, what if we did without repetition? What would happen to our boxes then? Well, the first would still be, but if we did not allow that letter to be repeated, the next one would be 30, then 30, then 30, then 30, then 31. So basically, we would be counting it down. The first would have 36, 35, 34, 33, 32, 31. And that is 1402, 41, 0240. So a lot less when we basically don't allow repetition. Another way of doing this is I could have done 36 factorial, and I want it to stop at 31. So I basically could, this means what, 36, 35, all the way down to 2 times 1. And I basically could cancel out everything before the 31, so divide it by 30 factorial, which would be 30, 29, 28, so on and so forth, all down. And what that's going to just leave us with is this first group. So 36 factorial over 30 factorial. Gives us that same answer. What if we only use numbers? Because there was a time that we only used numbers for license plates in California. So if we had 6 spaces, right, that would be with repetition, that would be 10 to the 6th. Or, is 1 million license plates enough? Maybe for the city, but for the state? We have 1 million drivers? Probably. You also got to keep in mind there's people like, who was the talk show? Jay Leno, and he has like hundreds of cars in and of himself. So the idea is this would not be enough, right? And I think when they initially did that, they also said, well, what if we did it without repetition? Well, 10, 9, 8, 7, 6, 5, 4. How about 4 factorial? And that's going to give us over 4, 151,200. Would that be enough license plates? Definitely not. Okay. So what we've done is we basically have kind of started to see all of the without repetition start getting us into what's called a permutation. When we're doing a permutation, we're saying the number of ways generally we can place an object or place. Okay. With permutations, when we're placing, the order matters. Or when I say matters, it makes a difference. So if I have 36 people and there are 6 seats, how many different ways could we place them? Well, the first seat we could put, second seat. Notice we can't repeat here because once somebody's sitting down, we have 1 less person. I think we already did that. 10240. What this is basically doing is it's using a formula for permutations. We are saying NPR. N is our number. R is how many we are placing. So this example, we are doing 36 people, and we're placing 6 of them. What goes on top? Well, n factorial. What goes on top? 36 factorial. But that's if we allow somebody to sit here and here and here. Doesn't make sense. So what we have to do is we have to cancel out where now it's 35, 34, 33, 32. I need to basically cancel out everything 30 and before. 30 factorial. Well, what is that? 36 minus 6. That is basically n minus r factorial. So that is the formula. Basically, you could do 36 factorial divided by 36 minus 6, 30 factorial, gives us this number. The good news is your calculator does actually have factorial also. If I go in the menu, I believe we are in probability. There's permutations. Try that again. And I thought this one had a menu. Let me double check. Probability number 2. Nope, it doesn't. So you have to basically put in the calculator n, comma, r. So for this in the calculator, I put NPR. Our n was 36. Our p was 6. So 36, comma 6. 36 place 6. Isn't that the same answer? So see that, yes, I can use the formula. Yes, the formula should make sense, but your calculator has a feature to do permutations. So I would be either comfortable with one of these two, but you're going to need to be able to do permutations with different groupings. If there were 36 people, how many ways could I choose 3 to be exempt from the homework? Now I got some of your attention finally, right? So here you have 36 people, and I'm choosing 3. This is not a permutation. This is a combination. Why? Well, because first time I'm picking 36 people. 36, right? Second one is here's why. Okay, I'm trying to think about this. Basically, the order doesn't matter. We are choosing. The order doesn't matter. Meaning, I don't care if I get chose first or second. I can go at the beginning and go at the end. So basically, this is kind of like we were doing with the letters in the word statistics. So when I do a 36, choose 6, and choose R, it starts off the same. We say, well, it's going to be n factorial over n minus r factorial. So that's going to be 36 factorial over 36 minus 6, 30 factorial. But the difference here is the order doesn't matter. If you get chose first or if you get chose last, and you're like, I got chose. So rearranging those people doesn't make a difference in this. So what we have to do is we have to say those 3 people, those 3 arrangements of those 3 people didn't make a difference, so we divide by another 3 factorial. We basically divide by r factorial. This is the formula for combinations. Okay? So it's going to be the same answer that we had before, but now divided by another 3 factorial. So if I set it up as a fraction, 36 factorial, we said 30 factorial, and 3 factorial. Way less, 233, 735. And what? 040. If I wanted to use a calculator, you can use NCR. There's going to be a command for this. It will be NCR, N, comma, R. So this would be 36, choose 6. Will be NCR, 36, comma, 6. In the menu, under statistics, there was, under probability, permutations. The next one under it is combinations. You have to fill in the 36, comma 6. Did I mess up? Oh, we're choosing 3. Somebody's like, call him a liar. All right, so this should have been 3. So this should have been 33. Sorry, I hope you were catching that while I was going. This is 36, and we're choosing 3. Okay? So what that does is up here, 36 minus 3 would be 33. Dang it. Try this again. Change that 30 to a 33. So and then, gee, I'll get this eventually. It would be 36, choose 3. Finally. Oh my goodness. So 7140. So yeah, sorry about that. I hope you were able to catch that though. But the issue is we have a lot less ways of this occurring because you don't care if you get chosen first, second, or third. So we end up with basically dividing it by another 6 or 3 factorial, and so we end up with way less options for this. Okay. All right. Sorry about that. We'll make it through. Now, standard deck of cards. What's the probability of getting a royal flush? Well, what is a royal flush? That's where you have a 10, jack, queen, king, ace that are suited. Okay? Well, how many suits are there? Well, there are 4 suits. So this can occur 4 different ways. So the probability of getting a royal flush is equal to, well, there's 4 different ways you can get a royal flush, over the total number of ways that we can get 5 cards out of how many are in a deck? 52. Does the order matter? If I got this 10 at the end, would that change my hand? No, it doesn't. I can rearrange the cards once they're in my hand. So since the order doesn't matter, is this going to be a combination or a permutation? Permutation placement, order matters. Combination choose. Did I write that down? Order doesn't matter. I did. So the number of ways that you can get 5 cards out of 52 would be 52, choose 5. So we have 52, I'll just use the choose here. Probability, combinations, 52, choose or comma 5. So there are, what is that? 2,598,000 and 960. And only 4 of them are royal flush. So 4 out of that. Very, very low. 3, 4, 5 zeros. Very low chance of getting a royal flush. That's why a lot of people haven't seen a royal flush. I have, and then that's the idea of odds. I know some people that have seen 2. How often do you have to play to probably see that? A lot. You probably have to spend a lot of money, but it is possible. But that's why they have such large payouts for the royal flushes. It's unlikely for it to occur by chance. All right, so some examples from the book. History Pop Quiz asks students to arrange following presidents in chronological order: Hayes, Taft, Polk, Taylor, Grant, Pierce. If an unprepared student totally guesses, what's the probability they get them all in the correct order? Well, wait a second. The order here matters, right? So there are 1, 2, 3, 4, 5, 6 presidents, and the order matters. So that would be a 6 permutation or combination. And we're ordering all 6. So 6p6, if I use the formula, Some of you are just going to go, well, it's just 6 times 5 times 4 times 3 times 2 times 1. Doing it logically doesn't hurt my feelings. But I think we've done that before. I think that was 720. There we go. Be careful though, that is not the probability of you guessing correctly. Okay? You're ordering all 6 of them. So the probability is that there is only one correct answer out of all the different ways that you can rearrange this. So 1 out of. So study for your tests, right? The probability of getting that correct if you're guessing, definitely better than a royal flush, but still Control Enter, pretty low, 0.0013. I think that 3 would become a 4 if we round. Okay? The Pennsylvania Match 6 Lotto. Winning a jackpot requires you select 6 different numbers from 1 through 49. The winning numbers may be drawn in any order. Find the probability of winning one ticket. Okay? So you're buying a ticket. You have 6 numbers. How many different ways can they be ordered? Does the order matter here, though? It says no. You can select them in any order. So is this a permutation or a combination? If order does not matter, that makes this a combination. So our N, we have 49 numbers, and we are choosing 6. If you like your formula, 49 factorial, 49 minus 6, and then another 6 factorial. I prefer to do combinations, 49, comma, 6. A lot of numbers, 1398. 1398, 3816. So that's the number of ways, or the different number of ways that those numbers can be kind of pulled out of there. But what's the probability? Well, the probability of winning, there's going to be one winning combination out of this is why the winnings are so high. So 7.15, do not put E negative 8. E means times 10 to the negative 8. Do not put 7.15 E negative 8. Will not allow that. Times 10 to the negative 8, or if you want a decimal, that's why that lottery is going to pay out a lot more than even the royal flush, because it's not very likely for that to occur by chance. So that should be kind of an overview of everything you need for the homework and for the quiz. So get working on that. Let me know if you have any questions.